Hello everyone, today we're going to look at the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2020 Test 5A Paper 2 Code ENF. So let's start with the first section, students. So this section contains 10 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with question number 21. If H2O2 solution labeled as 22.4 volume has density equal to 1040 gram per liter, which of the following will represent the concentration of the same solution? So students, if we talk about the volume strength and the molarity, we know that they are related as M equal to volume strength divided by 11.2. So if we put the value of volume strength over here, it is equal to 22.4. And if we divide this value by 11.2, we're going to get a value of molarity equal to 2 molar. So students, the molarity of this H2O2 solution is equal to 2 molars. Now if we talk about the percentage weight by volume, so molarity equal to 2, it means that 1 liter contains 2 moles. But when we have to talk about the percentage weight by volume, we have to deal in terms of the 100 ml of solution. So it means that 1000 ml, it contains 2 moles. It means 100 ml, it will contain 0.2 moles. So if we talk about the mass of these 0.2 mole, students, the molar mass is 34. We need to multiply the number of moles with the molar mass to get the grams. So in 100 ml, students, the grams of H2O2 is equal to 6.8. So students, the percentage weight by volume of this solution is 6.8%. Now if we talk about the molality and the mole fraction of H2O2, students, we can first find out the molality. So if we talk about the molality, we have the density of the solution and we have the molarity. So using these two numbers, we can find out the molality. So let us assume that 1 liter of the solution be taken. So if we talk about this 1 liter solution, students, the weight of the solution will be equal to 1040 grams. And out of these 1040 grams, students, the weight of the solute, which is H2O2, it is equal to 68 grams. Since the molarity is equal to 2. So if we talk about the weight of water or the weight of solvent, in this case it is going to be equal to 972 grams. Now if we talk about the molality, students, the molality will be given by moles of solute, which is equal to 2 divided by the kg of solvent. So the kg of solvent will come out to be this much, 972 by 1000. So this will approximately be equal to 2 point something. So the number which is given to us is very large. This will not be a match. Now if we talk about the mole fraction, students, we already have the moles of the solute, which is equal to 2 in 1 liter, and in that 1 liter solution we have the mass of water. So students, we can clearly see that the moles of water is going to be much greater than the number of moles of the H2O2 which is present. So the mole fraction will not also be equal to 0.5. So students, we can see that option C and option D are incorrect, whereas if we talk about option A and option B, they are correct. So students, for this question, we have to mark the correct answer as option A and option B. Let us look at the next question now. Question number 22. So we have been given a substrate. It is allowed to first react with NaBH4 and then it is allowed to react with H plus in presence of heat. Examiner seems to be interested in the product B, which is obtained at the end of the reaction. So students, if we talk about this NaBH4, so out of all the groups which are present over here, this NaBH4 is going to convert this keto group into alcohol. So if we talk about the compound A, students, I'll quickly draw the structure of A. This is going to be the structure of A. Now if we talk about the reaction of this compound A with H plus and heat, we're going to get an alkene over here. There is going to be acid catalyzed dehydration and the final product which will be obtained is going to be this. There will be aromatization in the system and we are going to obtain this product as the major product B. So if we look very carefully at the options which are given to us, we can clearly see that for this question we have to mark the correct answer as option A. Let us look at the next question now. Question number 23. A series of reactions have been given to us. The examiner seems to be interested in the major product P and T which are obtained during the course of this reaction. So students, if we talk about the substrate which is given to us, we can first talk about its reaction with acetic anhydride followed by tertiary butoxide. So if we compare the nitrogen and the oxygen, the nitrogen is going to be more basic. So the acetylation is going to first happen at the nitrogen. So if we try and draw the structure, so we can see that the amine group has been converted into the amide group. Now when there is a reaction with tertiary butoxide, it is going to cause a beta elimination, and the hydrogen which is indicated over here will get eliminated. So on reaction with tertiary butoxide, it is going to lead to the generation of a double bond at this position, while the alcohol group will remain intact. So this is the product P which is obtained. Now if we talk about the further reaction of P with this acetic anhydride, now it will be the lone pairs of oxygen which are going to attack the acetic anhydride. So this will lead to the generation of an ester. And now if we talk about the reaction of this ester with tertiary butoxide, there will be elimination again, and the indicated hydrogen will be eliminated. So this is going to lead to the generation of a double bond over here too. So this will be the product Q which is obtained. Now students, this Q is allowed to react with BH3 in presence of THF, and we have to talk about the addition of only one equivalent. So there will be hydroboration, deboration, and since both these double bonds are equivalent, we can add the alcohol to any of these positions. So students, let us assume that we obtain this product as the product R due to addition of one equivalent of the alcohol. So over here the anti-Markovnikov addition is going to take place, and the alcohol will be added to the terminal carbon atom. Now this is allowed to react with THCl. So when reacted with THCl, the alcohol will be converted into OTS. Okay, so this is the major product T which is obtained at the end of the reaction sequence. Now students, if we look very carefully at the options which are given to us, we have to comment on the structure of P and T, and if you look very carefully, we can clearly see that for this question we have to mark the correct answer as option B. Let us look at the next question now. Question 24. When sodium salt of H2PO4 minus is strongly heated, it produces. So if we talk about the strong heating of NaH2PO4, students, it leads to the generation of NaPO3. So if you look at the options which are given to us, you can clearly see that for question number 24, we have to mark the correct answer as option A. Let's look at the next question now. Question number 25. Which of the following given reaction is or are correct? So we've been given 4 different reaction, students, and we have to comment on whether these reactions are correct or not. So we start with option A. We have PTF6 reacting with O2 to give us O2 plus PTF6 minus. This is a correct reaction, students. We've learned about this reaction during the study of the compounds of xenon. If we talk about the second reaction now, we have XePTF6 reacting with PTF6 at 25 degrees to give us XeF5 plus PTF6 minus along with the formation of PTF5. So students, this is a redox reaction happening over here. You can see that the platinum is getting reduced whereas the xenon inside is getting oxidized. So this is a correct reaction. And now when it is further heated, students, it converts to XeF5 positive and PT2F11 negative. This is also a correct reaction. If we talk about the third reaction now, XeF6 reacting with RbF5 leading to the generation of RbXeF7 negative. This is a correct reaction, students. These alkali metal fluorides, they act as fluoride donors. If we talk about the fourth reaction now, which is the reaction of XeO3 with NaOH, it is going to lead to the formation of the sodium xenate. So this is also a correct reaction. So students, all of these reactions are correct, and for this question we have to mark A, B, C and D as the answer. Let us look at the next question now. Question number 26. Which of the following do not contain all 2 center 2 electron bonds and are not planar as well? So students, we have to look for those compounds which contain other type of bonds apart from the 2 center 2 electron bond, and they have to be non-planar. So students, we can directly eliminate the option B, I2Cl6. It is a planar compound. So it is not going to be an answer for this question. We have to deal in terms of those species which are not planar. So if you look at option A now, we have Al2CH3 whole 6. Students, this compound contains 3 center 2 electron bonds. So if we talk about option A, it contains 3 center 2 electron bonds and the aluminium is sp3 hybridized. So this is non-planar. So this will be an answer to our question. If we talk about option C now, we have Al2I6. So Al2I6 has a similar structure to Al2Cl6. There are 3 center 4 electron bonds present and the aluminium is again sp3 hybridized. So this also is non-planar. Lastly, if we talk about the structure of diborane, students, diborane also has 3 center 2 electron bonds like the A option, and the boron is sp3 hybridized. This is also non-planar. So students, all of these apart from option B satisfy the condition which is asked in the question. So for this question, we have to mark the correct answer as option A, C and D. Let us look at the next question now. Question number 27. A balloon of radius 10 cm is to be filled with a gas at STP from a cylinder. The cylinder contains the gas at 10 atmosphere at 27 degrees C. If the cylinder can hold 5 liters of water, calculate the maximum number of balloons that can be filled out of the following, assuming balloon to be spherical. So students, if we talk about the volume of one balloon, so the volume of one balloon, we can find out the radius has been given to us. So volume of balloon, let's call it as VB. It shall be equal to 4 by 3 into pi into r cube. So we can talk about the volume in liters itself, students. So we have the radius as 10 centimeter. So it will be converted into 1 decimeter. And we know that 1 decimeter cube is equal to 1 liters. So students, if we put the value of r as 1, then we are going to get the volume of the balloon as 4 by 3 into pi into 1 liters. Now students, this balloon has to be filled with the ideal gas. So we can first calculate the number of moles which can be accommodated in one balloon. So if I talk about the number of moles of the gas present in one balloon, that shall be equal to the volume divided by 22.4. So 4 by 3 pi into 22.4. So these many moles of the ideal gas can be accommodated in one balloon. Now we can talk about the total number of moles of air which are present inside the cylinder. So it is given to us that the cylinder can hold 5 liters of water. So the volume of the cylinder is equal to 5 liters, and the cylinder, it contains the gas at 27 degrees C and 10 atmosphere. So we can calculate the total number of moles of gas inside the cylinder under these conditions. So this will be equal to PV upon RT. So we just need to put the values. Pressure is 10 atmosphere, volume is 5 liters, the value of R is 0.0821, and the value of temperature over here is 27 degrees C. So it means that it is equal to 300 kelvins. So these many number of moles of gases are present inside the cylinder initially. So this is the initially. Now if we talk about the filling of these balloons from the cylinder. So students, the moles of ideal gas will transfer to the balloon as long as there is a pressure difference. As soon as the pressure becomes the same in the cylinder as well as the balloons are not going to fill up. So we can calculate the minimum number of moles that will have to be present in the cylinder, assuming that the pressure becomes 1 atmosphere. So if we talk about the number of moles of the gas in the cylinder, finally, that is the minimum number of moles that have to be present inside the cylinder. So that shall be equal to PV by RT again, and the pressure this time shall be 1 atmosphere. The volume is 5 and the R and the T values are the same, students. There is 0.0821 for R, and then the temperature is 300. So students, if we talk about the actual number of moles that are going to get transferred from the cylinder to the balloon, so we have to take the difference between these two numbers. So if I talk about the number of moles of gas actually transferred, this shall be equal to the difference between these two numbers, and that will come out to be 9 into 5 divided by 0.0821 into 300. So if we have to calculate the number of balloons that can be filled up, students, we just need to divide this number by this number. So if we talk about the number of balloons, let us call it as X. So X shall be equal to 45 divided by 0.0821 into 300 into 4 pi into 3 into 22.4. So students, this number will approximately come out to be 9.7. And if we look at the number of balloons which are given to us, we can clearly see that for this question, the answer has to be marked as option A, which says that there can be a maximum of 9 balloons that can be filled up under these conditions. So for question number 27, students, the answer is A. Let us look at the next question now. Question number 28. So we've been given an ester and it is allowed to react with ETO minus in presence of ETOH and leading to the formation of the major compound A. So students, if we talk about this reaction which is given to us, this is Claisen condensation, students, and in this reaction, the base which is present over here, it is going to extract an acidic hydrogen from the alpha carbon, leading to the generation of the nucleophile as shown. Now this nucleophile is going to attack another ester molecule which is present, students. So we can quickly draw the structure. So this will make an attack over here and this group is going to leave. So this is going to lead to the generation of a beta keto ester. So this is the major product A which is formed. So if you look at the options which are given to us, we have to talk about the correct statement, students. So option A, it says A is a beta keto ester. This is a correct statement. If we talk about option B now, alpha hydrogen of an ester is less acidic than the alpha hydrogen of an aldehyde or ketone of comparable molecular mass. So this is also a correct statement, students. Due to the stability of the conjugate base, the aldehydes and the ketones, they have a greater acidic alpha hydrogen as compared to esters, in which the resonance stabilization is hampered because of the cross conjugation by the lone pairs over the oxygen. So students, option B is also correct. If you look at option C now, product A is the beta keto ester which we had obtained. So this is also a correct option. If we talk about the last option which is given to us, compound X takes a weak base to deprotonate than does a ketone or aldehyde. So this is not correct, students. This statement is the opposite statement of option B, and we had seen that option B was correct. So students, for question number 28, we have to mark the correct answer as option A, B and C. Let us look at the next question now. Question number 29. The conductivity of a saturated solution of CaF2 at 25 degrees C was found to be 4.2 into 10 to the power minus 5 Simon centimeter inverse, and the conductivity of water used for making the solution was 2 into 10 to the power minus 6 Simon centimeter inverse. The molar ionic conductivities at infinite dilution for calcium 2 plus and F minus are 104 and 48 Simon centimeter square mole inverse respectively. We have to comment on the solubility product of CaF2. So students, let us first look at the mental map to solve this question. So we have been given the conductivity. So we have been given the kappa of the solution and we have been given the kappa of the water. So using these two kappas, we can talk about the kappa of the CaF2. Now students, if we find out the kappa and we can find out the lambda m value as well. Now using this kappa and the lambda m values, we can talk about the value of C, and using this C value, we can find out the value of KSP. So I hope the process for solving this question is clear to you guys. Let us try and solve this question now. So we'll have to first talk about the kappa of CaF2. So that will be the difference between the kappa of the solution and the kappa of the water. So kappa of CaF2 will be equal to 4.2 into 10 to the power minus 5 minus of 2 into 10 to the power minus 6. So this will be equal to 4 into 10 to the power minus 5 Simon centimeter inverse. If we talk about the lambda m value, lambda m of CaF2 is going to be equal to lambda m of Ca2 plus 2 times the lambda m of F minus. So we can quickly put the values. We have been given these values. So for calcium 2 plus it is 104, and for the fluoride ions it is 48. So it is 2 into 48. So this shall be equal to 200 Simon centimeter square mole inverse. Now students, using this kappa and lambda m, we can talk about the solubility or the concentration. So we know that lambda m is equal to kappa into 1000 divided by C for the given system of units. So we can just put the value of C as kappa into 1000 divided by lambda m. So we can put the values now. Kappa is 4 into 10 to the power minus 5 into 10 to the power 3 divided by lambda m, which is 200. So this on simplification, students, gives us a value of the C equal to 2 into 10 raised to power minus 4 molars. So if we talk about the KSP now, the KSP shall be equal to 4 into C cube. So this shall be equal to 4 into 8 into 10 raised to power minus 12. So this on simplification gives us a value equal to 3.2 into 10 raised to power minus 11. So students, if you look at the options which are given to us, we can clearly see that for this question we have to mark the correct answer as option B. Let us look at the next question now. Let us look at question number 30 now, students. If we plot the graph of radial wave function versus distance from the nucleus, in which of the following the sign of wave function does not change? So students, if we talk about the graph of radial wave function versus the distance from the nucleus and the sign of the wave cannot change, so it means that there must be no radial nodes present inside that orbital. So if we talk about the orbitals which do not have any radial nodes, so they have to satisfy the condition n minus l minus 1 is equal to 0, which means that n minus l should be equal to 1. And now if we look at the options which are given to students, we can see that for option A, the difference in n and l values is equal to 1. If we talk about option B, this also has a difference between n and l value equal to 1. And if we talk about the third option, this also has the difference between n and l values equal to 1. However, if we talk about the fourth option, in this case the difference comes out to be equal to 4. So this will not satisfy the given condition. So students, we can see that for this question we have to mark the correct answer as option A, option B and option C. Let's look at the next section now, students.